In section 13.3, we are factoring ax squared plus bx plus c when a is not equal to 1. So this just means that then my leading coefficient will be any other number except 1. We're still going to use the Berry method to factor these polynomials. What's going to change just a little bit is instead of when we divided out whatever they had in common, it was always 1, now we might be able to divide out another number besides 1. But the process is exactly the same. So looking at the first example, we have 3x squared minus 10x minus 8. First thing we always look for is there a GCF? There is not a GCF other than 1, so we can move on and write down our A, B, and C. Our A is 3, our B is negative 10, and our C is negative 8. And so A times C is 3 times negative 8, which is negative 24. That means we have to have one positive and one negative number. So we have 1 and 24, we have 2 and 12, we have 3 and 8, and we have 4 and 6. Now because our middle term is negative 10, that means that the bigger number is negative and the smaller number is positive. So everything on the left is going to be positive, and everything on the right is negative. And so the first combo gives me negative 23, the second one gives me negative 10, the third one is negative 5, and the fourth one gives me negative 2. We're looking for negative 10, and so 2 and negative 12 is what we're looking for. This time my leading coefficient is 3, so we bring that down into both pieces, and we split our x's just like last time. The missing pieces go in our blank spaces, so plus 2 and negative 12. And then we want to see what we can divide out of both. So between a 3 and a 2, I can only divide out a 1. But between 3 and 12, I could take a 3 out. So the first one stays exactly the same, 3x plus 2. And then when I divide a 3, I end up with x minus 4. And that is your final answer. Let's go ahead and try another one. Example number 2, we have 24x squared minus 76x plus 40. First thing I'm looking for is a GCF, which I know I'll be able to take something out because they are all even, so I know I at least can take a 2 out, but I can take something a little bigger out. I can take a 4 out. So when I take a 4 out, I have 6x squared minus 19x plus 10. And so now we want to use the Berry method on 6x squared minus 19x plus 10. So A is 6, B is negative 19, and C is 10. And so A times C is 6 times 10, which gives me 60. With positive numbers, we have those two options. It's either 2 positive or 2 negative. But because B is negative 19, that means we use the 2 negative numbers. So my factors of 60 are 1 and 60. We have 2 and 30. We have 3 and 20. We have 4 and 15. We have 5 and 12. 6 and 10. And that's it. So let's go ahead and figure out, we know that both of these are negative, and we're looking for the combo that gets me to negative 19. And so negative 4 and negative 15 give me negative 19. So we still have our 4 up front that we took out to begin with. We bring down our leading coefficient of 6 into both, and we split our x's. And then our missing piece is -4 and -15. The last step is to divide out whatever they have in common. So between 6 and 4, I can divide out a 2. And between 6 and 15, I can divide a 3 out. So we have 4 times 3x minus 2 and 2x minus 5. And how can you always check yourself if you're not sure if you did it correctly? You could always multiply this entire thing out, and you would get the original polynomial of 24x squared minus 76x plus 40. Let's try another one. We have 10x squared plus 37x plus 7. Do we have a GCF that we can take out? Between 10, 37, and 7, no we don't. So A is 10, B is 37, and C is 7. So A times C is 10 times 7, which is 70. With that positive number, we have 2 options. And because the middle term is positive 37, that means that we use the 2 positive numbers. So factors of 70 are 1 and 70, 2 and 35, 5 and 14, 7 and 10, and that's it. We know that they are both positive numbers, and we're looking for the combo that gets me to positive 37, which is going to be the 2 and the 35. And so we bring our leading coefficient down of 10 into both, and we split our x's. Our missing terms are 2 and 35. And then we want to divide out whatever they have in common. So between 2 and 10, we can take out a 2. And between 10 and 35, we can take a 5 out. And so we end up with 5x plus 1 and 2x plus 7. And one more. We've got 6p squared minus 13pv minus 28v squared. So GCF is always the first thing. I can't take anything out between 6, 13, and 28. And so my A is 6, my B is negative 13, and my C is negative 28. And so A times C is 6 times negative 28, which is negative 168, which means we have to have one positive and one negative number. And so let's go ahead and find all the factors of 168. So we have 1 in 168. We have 2 and 84. We have 3 and 56. We have 4 and 42. We have 6 and 28. We have 7 and 24. We have 8 and 21. And we have 12 and 14. Because we want a negative 13, that means that the bigger numbers are negative and the smaller are positive. So everything on the left is positive and everything on the right is negative. The goal is to get to negative 13. So which combo does that? Well, 8 and negative 21 are negative 13. And so we bring our 6 down into both pieces, and we're going to split the P. We have our 8 and our negative 21, but what we're missing is the V. So we just tack that on at the end. And then we want to divide out whatever they have in common. So between 6 and 8, we can divide out a 2. And between 6 and 21, we can divide out a 3. So what I'm left with is 3P plus 4V and 2P minus 7V.